Well, dear students, now today I have some questions which are asked in competitive exam like any NEET and AIEEE and JEE. Here in this tube, U2, here initially water was filled up to this position and this side was oil. Now oil is poured in the U2 till water rises from one position 65 centimeter above, and the liquid remain 1 meter. The level of liquid remain 1 meter above the free surface of water. I am telling you again, in this tube, water and oil were filled. Water and oil filled, and situation was like this. The water was here and liquid was somewhere else. Here. This is the original position of water. यहाँ तक ही water था, कहीं तक. Now oil was poured into this tube till water rise 65 millimeter above the original level, while the free level of oil remain 1 meter above the water level. So you are asked what is the density of oil? What is the density of oil? So situation is simple. As we know, density of water is 1000 kg per meter cube. Density of water. Density of water, remember it. If not given, we have to apply 1000 kg per meter cube or 1 gram per centimeter cube. Actually, the pressure of this liquid column is balanced by the water column. Height of water column is 130 millimeter, or you can say 13.0 centimeter, and height of oil is 131 because it is 1 centimeter, 1 millimeter above. 1 or 10, sorry. It is 10 millimeter, sorry. 10 millimeter. यानी 1 centimeter. So pressure of water column equal to pressure of liquid column, and pressure of liquid column, oil column. This is oil. So height of oil is 131, यानी कि 13.1 centimeter. अगर मीटर के -2 into density into G is equal to this height 13.0 10 to power -2 height of water column, density 1000, and G cancel, -2 cancel. So it is D is equal to 13 into 10 to the power 3 upon 1, 13.1. 13.1. Is that clear? And now it is 13,000 into 10,000 upon 131. If you divide this, you will get 928 nearly. 928. Sorry, it is 14 here. 14.10 millimeter, no, 1 centimeter. So 1 centimeter plus 13 centimeter, sorry, 14. It will be here 14 only. Sorry, I am sorry. Here height of water OM column, actually it is 113 millimeter, 13 centimeter. It is 10 millimeter centimeter, so it was 14 centimeter. So now if you divide, you will get 928 kg per meter cube. These are some simple questions which this question has been asked in NEET 2017. Now there is other question here. Very interesting. I told you principle of flotation. I told you that a body will float, partially submerged or complete submerged if weight of body equal to weight of liquid displaced. Here the question, a solid cylinder is suspended by it is cylinder here. Its length is L. It is submerged such that half of the height is liquid. Total length is L. Total length is L. And L by 2 outside. L by 2 inside. This is massless spring. Massless spring. So you are asked here. एक्सटेंशन इन द स्प्रिंग, इसका जो एक्सटेंशन हो रखाने पर हाउ मच विल बी द एलोंगेशन इन द स्प्रिंग कांस्टेंट के is the spring constant, and this cylinder here of density length L, mass M दिया हुआ है, mass of this capital M. I am reading question. A uniform cylinder of length L, mass M, having crossing area A. This crossing area A is suspended with its length L vertical from a fixed point by a massless spring, such that half submerged in liquid of density rho. Density of liquid rho. So you are asked what is the elongation. There are some options. So we have to find out how much is the extension. Actually, spring when pull apply force F is equal to Kx, and this force will be equal to weight of solid cylinder. And I told you when a body fully or partially was liquid, body loses weight, and that loss of weight of body equal to weight of liquid displaced. So liquid displaced होगा this much. And remember, mass equal to volume into density, and volume equal to area of base into height into V. और अगर वेट करना है तो भाई ये मल्टीप्लाई बाय जी. टोटल वेट, तो here Kx will be weight of cylinder, that is A L, तो volume of cylinder into density मानो D है spring और into G minus weight of liquid displaced. The weight of the cylinder will be equal to weight minus loss of weight, and loss of weight will be A into L upon 2 or density of liquid sigma into G. From here we will get answer. A L D G. It is mass, capital M given mg, minus A L sigma upon 2G. I take here mg common, so 1 minus G can outside L sigma upon 2m, because G will get cancelled. So X is equal to mg upon k into 1 minus A L sigma upon 2m. I simply applied principle of flotation here and Archimedes principle here. I told you Archimedes principle that when a body fully or partially when liquid, body uses weight, and the weight of loss of weight of body equal to weight of liquid displaced. Cylinder has displaced this much volume of liquid outside. Its volume is A into L by 2. The volume of this density sigma r into G. तो हमारा जो वेट ऑफ सिलेंडर था उसमें से ये कम हो गया, तो नेट फोर्स ऑन द स्प्रिंग विल बी दिस. आई होप यू हैव गॉट इट. नाउ देयर आर सम अदर गुड क्वेश्चन आल्सो. Dear student, please make note of question when I tell, because it is difficult for me here to write the complete text of the question here. You please understand and try to understand. These questions are, this last question was asked in JEE Mains 2013. Now other question is there, AIEEE 2008. Here two miscible liquids are filled here. This is another liquid here. These are two immiscible liquid. Liquid one of density rho 1. It is liquid 2 with density rho 2. Here a spherical body. A jar is filled with two non-mixing liquid 1 and 2 having density rho 1 and rho 2 respectively. A solid ball made of material of density rho 3. एक यहाँ पर रो 3 सॉलिड बोल है, इसकी डेंसिटी रो 3 is dropped in the jar. It comes to equilibrium in position as shown. Which of the following is a correct relation? यहाँ रिलेशन दिया हुआ है, ऑप्शन दिए हुए हैं. नंबर ए ऑप्शन है रो 1 लेस देन रो 2 लेस देन रो 3. बी ऑप्शन इज देयर रो 1 लेस देन रो 3 लेस देन रो 2. नंबर सी है रो 3 लेस देन रो 1 लेस देन रो 2. एंड डी ऑप्शन इज देयर रो 1 ग्रेटर देन रो 3 greater than रो 2. I explained you while starting this chapter principle of flotation. I told you that a solid body will float in a liquid if density of solid is less than density of liquid. So here, because the sphere is floating inside rho 1, it means density rho 1 is less than rho 3. When a body floats, I told you V dash upon V equal to D upon D dash. Density of solid body, density of liquid. If this density less than this, then V dash का volume inside less than V. और D equal to D dash, तो body floats completely submerged. तो फंडा ये है, this is the fundamental here. A body will float only in a liquid if its density is less than density of liquid. Here rho 1 is lighter less than rho 3, that's why it is completely submerged. But here it is partially submerged in this loop. So we can say कि rho 1 less than rho 2 क्योंकि ऊपर है और less than rho 3. तो rho 3 less than rho 2 है, ठीक है. Rho 1 less than rho 3 है. So this is the correct answer. I think you have got it my point. A body floats, any body or any liquid floats, है ना, over a liquid when its density is less than in which it is floating. So because liquid 1 is above liquid rho 2, so density of liquid 1 less than rho 2 है. Rho 3 is the density of body. It is totally inside liquid 1, rho 1 density. So rho 1 less than rho 2 है, rho 3 less than rho 2 है. I think it is clear now. Now other question there. There are some good questions here which are asked. Again you are given 4 diagrams. Actually 4 diagrams are there. I am drawing here. Water, here is water, oil, and a ball floating here. ठीक है भाई. B option is there. It is A figure. B figure is there. Water below. There is water, and it is oil, and ball floating here. C diagram. Again water here, oil here, ball floating here. And D part, water here, oil here, and ball is floating this one. So here you are asked a ball made of material of density rho. Density of ball is rho. Ball density rho, water density rho W, and that of oil rho oil. You are given like this. So a ball is made of density rho, where rho oil less than rho. Rho oil less than rho or less than rho water. So which of the following diagram is correct? Density of oil less than density of water. So certainly water will be below the oil. So here water below, ये दोनों गलत हो गए. Because density of water is more than that of oil. Have your thing sink inside. So I think you have got my point. And the density of ball is less than water. So density of ball less than water here, density of oil less than this. So ball will sink in oil and will float past the submerged in water. So this D diagram is correct. A, B, C, D. This diagram is correct. Ball density is less than water, so floating submerged, and more than oil. So ball will sink in oil. So it is correct. These are questions you can find out. These questions from question bank. This question was asked in 2010. IEEE 2010. So please learn principal flotation, learn density, learn. There are so many things here which you don't learn. Now there is another question again on precipitation and density. Two immiscible, two non-mixing liquids of density rho and density n rho, and greater than 1. And this density higher than this are put in a container. The height of each liquid is h. A solid cylinder of length L and density D is put in this container. the cylinder floats with its axis vertical with length PL, where P less than 1 in the denser liquid. The density of liquid, density equal to, बस सिलेंडर है देखो ये कह रहा है here two immiscible liquids equal height as था, here a cylinder is floating here with vertical axis, density this rho, this is n rho, है भाई n less than 1, greater than 1, this is heavier, n greater than 1, so liquid, suppose it is 1, it is liquid 2, so liquid 2 is heavier than 1. This solid cylinder of length L is floating with its length PL inside the denser liquid. So how much is this? ये लेंथ कितना होगा L माइनस PL, तो इसकी डेंसिटी है D. Density of material of solid is cylinder is D. So what is density D? What is density D? So it is floating completely somewhere inside the liquids. So weight of body, weight of cylinder equal to weight of liquid displaced by liquid of density rho and plus density weight of liquid displaced 1. Both the liquids are displaced. It is floating in equilibrium, so weight of cylinder is equal to weight of liquid 2, weight of liquid displaced, weight of liquid 2 displaced, plus weight of liquid 1 displaced. So very simple. This area is A, suppose ALDG is the weight of cylinder. It is equal to weight of this liquid displaced. The height is area L, A, or it is PL, the volume, into density. दी है ना क्या? हाँ रो. Sorry, rho into n into rho, into G. A into PL is the volume of this liquid into density into G here, plus this height is area to A bracket L minus PL, I mean volume into density rho or into G. So from here you have to find out this density. L यहाँ से कॉमन समझ आ जाएगा, L कैंसिल हो जाएगा, A कैंसिल, ये L कैंसिल हो जाएंगे, G कैंसिल, बचा रहेगा यहाँ D इक्वल टू, ये होगा यहाँ आपका NP रो प्लस it is 1 minus rho into 1 or minus P into rho. If I take here rho common, then it becomes 1 plus NP minus P, or you can write rho into 1 plus P into n minus 1. This is this height. Okay. So these are some questions based on principle of fluctuation, density, pressure of liquid, etc. We'll meet then with next.